Alright everybody, what's going on? This video we are going to look at three-dimensional coordinate systems. Alright, so I'm going to warn you now, I'm not the best at drawing, so my drawings may not look that good. You can look in a textbook and see better drawings than what I can draw by hand. Alright, so let's get started. So it says we have any point in space is represented by an ordered triple ABC of real numbers. A, B, and C are the coordinates of the point. So the three coordinate axes determine the three coordinate planes. Alright, so here we have the x-axis, we have the y-axis, and we have the z-axis. Now, I don't know if you can see this dotted blue line here, but this x-axis, this is going in the positive direction, and it extends out this way, and these are the negative values of x. And same thing here with y, these are positive y values, and if we continue back this way, those are negative y values. And then we have the z-axis. This is the positive direction here, and if we continue on down, then that's negative z values. And you can see that this right here, this plane right here, that's the xz plane. See the x-axis and the z-axis, this would be your xz plane, and then the z-axis and y-axis, that would be your YZ plane, and then the x-axis and the y-axis, that would make up your XY plane. All right, so these three coordinate planes divide space into 8 parts called octants. All right, so it's hard for me to draw this, but basically you've got to understand this plane continues on this way, and it continues back this way like this, and we have, let's see if I can draw this like this. See, they continue on like this. You see, they keep going, and you've got like one back here, one here, one here, and then this one in the front. That's 4 of them right there. And these are all, above the XY plane. And then you've got the same 4. See, they extend down also. See, they come down this way. And that would be below the XY plane. And that would be 4 more for 8 total. And then the first octant, which is in the foreground here, this area right here, is determined by the positive axes. So that's determined by the x, y, and the z. This would be your first octant right here. All right. So hopefully that made sense. I know my drawing's not that good, but you can look in a book and it'll have a much better drawing than what I just did. All right, so now let's look at points. So we have a bunch of points here. We have let's look at the point Q real quick. All right, so point Q has coordinates A, B, 0. So we go out A on the x-axis. See, A is how far you move on the x-axis, and then B is how far you move on the y-axis. So we got A, and then we got B, and then they meet right here for your for AB, and then there's no elevation. It's not going up or down, so Z would be 0. And let me label this. This would be your x-axis, your y-axis, and your z-axis. And so this would be your point Q, okay? And look at this. Point Q is called the projection of P onto the XY plane. See, it's on the XY plane here. Now let's look at R and S. So here's point R. So you can see for point R, X is 0, so we don't move anywhere there. And then we move B units on the Y-axis and then C units on the Z-axis. And so that point would be right there. And R is a projection of P onto the YZ plane. See, it's on the YZ plane right here. And then the point S, well, A is your X coordinate, so we move A units on the X-axis, 0 units on the Y-axis, and then we move up C units on the Z-axis. And so that would be point S, and point S is a projection of P onto the XZ plane. See, it's on that XZ plane right here. All right. So I hope all that made sense. But yeah, that's how you would plot your points. All right. So let's look at a couple of examples here, and let's plot these points here. All right. So let's just come here and make 1, 2, 3, 4, 5. See, I got Z is -5, Y is 3, 1, 2, 3, and X is -4. So I've got 1, 2, 3, 4. All right. So remember, this is your positive direction on the X-axis. This is the negative. This is the positive on the Y. This back here is negative. This is positive on the Z. This is negative. All right. So let's see if we can't draw this. All right. So I want to plot the point -4, 3. So I've got -4, which is right here. All right. And that's on the X-axis. The Y-axis, that's 3. And so that's going to come like this. We'll draw a box. And then I've got, let's see. All right, -5 on the Z-axis. So that's down here. Okay? So let's see if we can't draw that. So that's going to come down here. We'll come down here like this. And let's see, we'll be right. That's not a very good drawing, is it? All right, so -4, and then we got the 3, and then we've got -5 on the Z-axis. So that's gonna be something like that right there. All right. I know it's not very good. Let's see. Let me try that again. All right, let's do that. Let's do this. Let's come down here like this. And it would probably help also if my tick marks were all evenly spaced, which they're not. So that'll have something to do with it too. All right. So and you can see we went this way on the X-axis, and then we can join this, and let's see. Let's come down. Whoop. Let's come down here like this, and then we'll go across. And then let's see. But anyway, this is your point right here. Okay. This is your point. It's going to look something like this. Okay. I know that's not very good. Something like that. But this would be your point, -4, 3, -5. And like I said, I could, drawing the tick marks better, it would make it look better. Sorry about that, but you get the idea. You move along the x-axis, the y-axis, and the z-axis, and it's where they're going to come together here at this point. All right, so that's this point. Now let's look at this one. So I've got, let's see, I've got 1, 2, 3, and then the y is -2, 1, 2, and z is -6, 1, 2, 3, 4, 5, 6. All right. So, let's plot 3. So there's 3. That comes to here. Okay. Y is -2. So the -2 on the y would be right here. So we're coming like this right here. So it's gonna look something like this. All right, and then we've got -6 on the z. There's -6. So I'm gonna come down here. Let's see. Let's come down here like this. Maybe something like that, where they all come together. Okay, so the point is going to be right here. See where we came out from where it's 6. We came out from there, probably down a little further. All right. And so our point would be about right there. All right. So this would be the point 3, -2, -6. So, it can be kind of difficult to plot the points, on paper, but, understand that this tells you how to move on the x-axis, the y-axis, and the z-axis. Okay. And so there's your point. All right. So hopefully that wasn't too confusing to you. All right, so here we've got the Cartesian product R. This is the real numbers. That's the set of all x, y, z, set of all points x, y, z, such that x, y, and z are elements of the real numbers. It's the set of all ordered triples of real numbers and is denoted by R3. Okay, so instead of writing this, we write it like this right here. Okay. All right, so in terms of coordinates, the first octant can be described as the set of points whose coordinates are all positive. Remember, we talked about the first octant up here earlier. That's this part right here. And see, if you're in this first octant, then your x, your y, and your z, they're going to all be positive. Okay, see, we're not coming back here like this, where x is negative, back here y is negative, and down here z is negative. All your x, y, and z, they're all positive. All right, so let's see. All right, in two-dimensional analytic geometry, the graph of an equation involving x and y is a curve in R2. In three-dimensional analytic geometry, an equation in x, y, and z represents a surface in R3. Okay, so when we're in 2 dimension, that's going to represent a curve, and when we're in 3 dimension, that's going to represent a surface. All right, so let's look at some graphs of some surfaces. All right. So it says, what surfaces in R3 are represented by the following equations? So let's just look at number 1. Let's look at z equals 3. So what is z equal 3? Well, z equal 3 represents the set x, y, z such that z is equal to 3. Okay, so that's the set of all points in R3. Okay, the set of all points in R3 whose z coordinate is 3, and x and y can be any value. So what do you think this is going to look like? Well, if we draw this, let's see what we've got here. So let's draw this. There's x, y, I'm sorry. There's x, y, and z. And so z equal 3, 1, 2, 3. That's going to be right there. Okay, and let me take this and let me move this down some. All right, so that's this. So remember, the x and the y, they can be any points, but the z value is going to be 3 at all times. So what that's going to look like, that's going to look something like this. Let's see if I can draw this half decent. All right. So what it is, and see, this is 3 right here. So what this is a horizontal plane. Okay, so you got to understand that this thing is it's parallel to this XY plane. Okay, it's just, it has an elevation of 3. Okay, and so that's what it would look like, this horizontal plane right here. All right, and so that's what number 1 looks like, z equal 3. All right, so now let's look at the next one. Okay, this is z. Let's look at y equals 5. Okay, so the equation y equals 5, that's the set of all points in R3 whose y coordinate is 5. Okay, whose y coordinate is 5, and this is, what do you think this is? Well, let's come over 1, 2, 3, 4, 5. There's 5 right there. So what do you think this looks like? Well, all the y values are 5, and x and z can be anything. So this one's going to look like this. Whoop. That's not a very good drawing at all, is it? Let's do that again. Like that. And this is y equals 5. So that's going to be a vertical plane. Okay? All the y values are going to be, well, I didn't draw that right, did I? Let's see. I didn't draw that right. That's going to be like this. Something like that. Okay. This is 5. So you got to realize this plane right here is 5 units. It's vertical. It's parallel to this z-axis here, and it's 5 units away. And this is just a plane, a vertical plane. All right. So that's what that would look like. Now let's think about this right here. What if we were in R2? Think about being in R2. What would this right here look like y equals 5 if we were in R2? Well, if you look at this XY coordinate system, there's y equals 5. That would just be a horizontal line, wouldn't it? If we were looking at it in R2, and you see the difference. And this over here, we're in R3. See, this is just a curve. It's a line here. And then this is in R3, where it's a surface. Okay? So, just like I told you at the beginning, I'm not the best at drawing, so I do my best. All right, so let's look at this. It says which points x, y, z satisfy the equations x squared plus y squared equals 1 and z equals 3. All right, so let's look at part A, and let's draw our there's x, there's y, and there's z. And we want what? We want x squared plus 1 equals 1. Well, what is that? Well, think about if you were looking at just the XY coordinate system. What is that? That's a circle with radius 1, right? That's a circle with radius 1. The center is at the origin. Okay? And here's the origin right here where the X, Y, and Z axis come together. All right, so this is a circle. So look at this like we're looking down on this XY coordinate system. So that would just be a circle, right? That would be a circle. See, if you were standing up here looking down, it would look like this right here. You see that? See, this axis would be coming this way, and this would be going back this way. Okay, so if you were standing up top and looking down, you would see this right here. But so why did I draw it up here? Well, because it tells me z is equal to 3. So that means all the points right here, all these points are at an elevation of 3. This is at an elevation of 3. And so that's what that would look like. That would be the graph of that. Okay, or that would be the points that satisfy that equation. It would be the ones on this circle here. All right. So let's look at the next part. It says, what does the equation x squared plus y squared equal 1 represent as a surface in R3? All right, so, well, it's the same thing, right? It's this right here. We've got that drawn, all right? But what's the difference here? What's the difference in this problem here? Well, they don't tell us that z equals 3, do they? They don't tell us z equals 3. So what this would do, this would represent all the points. It would be like a cylinder, okay? It's gonna continue up and continue down. I mean, of course, we're not gonna draw the whole thing, but it would look like this. It would look like a cylinder because there's no restriction on z. All right, so basically what this means is that this x squared plus y squared equals 1 represents a surface in R3. Okay, what that means is that's going to consist of all the horizontal circles x squared, let's see. All right, I had a little technical difficulty there. My program locked up. I had to restart it. All right, so what this represents is all the circles x squared plus y squared equals 1. Okay, it represents all the horizontal circles. X squared plus y squared equals 1. And z can be some number k. Okay, that's going to tell you the elevation of the, like, see, in the first part, this right here was 3 units up, but then we could have one 4 units, 5 units, 6 units, okay? 3.001 units up. It's going to represent all those circles. And so this would be your surface right here. All right. So let's look at this one. So describe and sketch the surface in R3 represented by the equation y equals x. So what would that look like? Well, let's draw it. And I'm going to draw this one a little bit different so we can see it better. So we're going to call this x, this y, and this would be z. And so so this is going to be your positive x, positive y, and this is going to be your positive z right here. All right. So if we drew the line y equals x, what does that look like? That's this line right here, right? So we know that line's going to come in like this. You see that? It's going to look like this. So it's going to look like this. Okay, let me draw it slanted a little more. So it's going to look like this. Something like that. And then it's going to go up. And then it'll go up this way a little bit. So it's going to be this plane right here. See this line here? It's, kind of like at a, how this is like at a 45-degree angle. Well, it's coming this way, and then it's a plane that just keeps going up and down and this way and this way. All right. And so that's what it would look like. And, I know some of these can get confusing, drawing them. It's going to take practice. I mean, like I said, I'm not the best at drawing these either. So, all right, so let's look at this. It said we've got the distance formula in 3 dimensions. We know how to find, do you remember from algebra, we know the distance between 2 points. If we have a line segment, remember that? And we call this x1, y1, and we call this one x2, y2. Well, what's the distance between the 2 points? Well, remember the distance is what? x2 minus x1 squared plus y2 minus y1 squared. That's the distance between the 2 points. But what if we want the distance in 3 dimensions? Okay, so let's look at that. So the distance formula in 3 dimensions, the distance P1, P2, okay? So I've got a length from P1 right here to P2. So we're actually looking for, let me draw this in a different color. We're looking for that distance there. Okay? And once again, I know my drawing's not the best, but anyway, there it is. Okay, we're looking for that distance. All right, so see the distance from P1 to P2. See, here's P1, and here's P2. The coordinates are x1, y1, z1, x2, y2, z2. So that distance is just x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. It's similar to the formula for the distance between 2 points when we're in 2 dimension, right? We added on this z2 minus z1 squared. All right. So let's just look at this, and and let me show you. Let me show you how we get the formula. All right, so to get this, let's look at a few things. Okay. Do you see this right here? This triangle right here. That's a right triangle. Okay, that's a right angle right there. And then we have this triangle right here. Okay, this is a right angle right here. All right. So let's look and see how we get this distance. Well, this distance here, it would be this distance squared is equal to this distance squared plus this distance squared, right? Pythagorean theorem. See, this is the hypotenuse. It's opposite the right angle. So it's this squared equals this squared plus this squared. So there's a few things we need to write down before we do that. Okay. So, I mean, I know this distance. Okay. I know what this distance is. The distance between B and P2. Okay. Because see, I need the length of this side and I need the length of this side. So if I get P2, that distance, that is equal to what? Z2 minus Z1. All right, so that takes care of this. But now I need this distance here. That's from P1 to B. So what is that gonna be? Well, I need what? The length of that. That's a diagonal. Okay, that's a diagonal. So if I can get the distance from this side, if I can get this distance and I can get this distance, then I can use Pythagorean theorem to get the length of this side right here. All right. So I've got the distance P1A, say from this point to this point. Well, that's going to be what? X2 minus X1, right? See, this is traveling along the x-axis. See, this one was traveling along the z-axis, so I just subtract the z values. This one's traveling along the x-axis, so I'm just going to do x2 minus x1. And then I need this distance right here. You see that? I need this distance. So this distance, that's traveling along the y-axis, and I guess I could go ahead and label this x, y, z. Okay, so now I've got the distance A to B. So the distance AB is equal to what? Y2 minus y1. See, from here to here, that's going to be the y2 minus the y1. All right. So let's look at this. So now let's write down the distance from P1. Whoop, I don't know why I wrote an R. From P1 to P2. Okay, so that's the distance from P1 to P2. That's going to be what? That's going to be P1. See, here's P1 to B, that distance. So that's going to be P1 to B, and of course that'll be squared. I'm using Pythagorean theorem, and this is squared plus. Okay, so see, this is from P1. Let me bring it down a little bit. From P1 to P2, that's the hypotenuse. So it's the hypotenuse squared equals. All right, so let's see, we did P1 to B. It would be this side squared plus what? Plus this side squared. So that's going to be plus BP2 squared. All right. So hopefully everybody's good with that so far. All right, so look at this. B, P2, the distance between B and P2, well, I know what that is. That's Z2 minus Z1. You see that? But what about this P1 to B? What is P1 to B? Well, if I come over here, let's do this in a different color. I've got P1 to B squared, okay? So what I'm doing here is I'm getting the length of this, P1 to B. Well, it's this side squared plus this side squared, right? So that's going to be P1A squared plus AB squared. That's this distance right here. It's this side squared plus this side squared. All right. So now what I'm going to do is I've got P1 to P2 squared is equal to P1B squared. Okay. So what is that? Well, that's this right here. All right. But I think what I'm going to do, I'm going to write the P1A squared. I'm going to write that one first. Okay. And I'll show you in a minute, or you'll see in a minute while I'm writing it first. I'm writing it first. See, that's the P1A. P1A. Let's see, where's that? All right, so I'm writing it first because that's going to give me the X coordinates first, and then I'll have my Y, and then I'll have my Z. But then again, P1B squared is P1A squared. Well, P1A squared, and then plus AB squared. And so that's going to be plus AB squared plus BP2 squared. All right. So all I did here is I took this and I replaced it with this. See, this is equal to this right here. All right, so now let's see if I can squeeze this in. So now I'm going to get P1, P2 squared is equal to, well, what's P1A squared? P1A, that's that is x2 minus x1 squared, okay? And then plus AB squared, that's y2 minus y1 squared, plus, and then BP2 squared, that's going to be z2 minus z1 squared. And so this gives me P1, I wrote an R, P1, P2 squared is equal to x2 minus x1 squared. Since we're squaring it, that's going to give us our positive number, y2 minus y1 squared plus z2 minus z1 squared. And then all I do is what? I take the square root of both sides, and so that's going to give me P1, P2 is equal to the square root x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And there's your distance formula right there. See? There it is right there. But that's how you can go about getting it. Okay? All right, so let's look at an example. It says find the distance from point P, which is 2, -1, to the point Q, 1, -3, 5. All right, so, it's easy. So what's the distance? PQ? Well, that's what? That's the square root, x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared, the square root of that. That's what it is. Okay. What I would recommend whenever you're doing doing math and you have a formula you have to remember, what I would do is every time you work a problem using that formula, write the formula down. If you write it down enough, you're going to remember it. Okay? And so what we can do, we can call this x1, y1, z1. We can call this x2, y2, z2. And it really doesn't matter which one you call the x, y, z1 or x, y, z2. It's really not, you're going to get the same answer either way. All right, so when you're finding the distance. And so that's going to be x2, that's going to be 1 minus 2 squared plus negative 3 plus 1 squared plus 5 minus 7 squared, which that's going to give us the square root of 1 plus 4 plus 4, which equals 3. And that's the distance between the 2 points. Between, it's going to be 3 units. Okay. All right, let's look at the next one. All right, find an equation of a sphere with radius r and center CHKL. All right, so let's draw a picture. Let's see if I can make this look halfway decent. All right, so we got X, Y, and Z. And let's say out here we have a sphere, okay? And we've got the center of the sphere is HKL. There's the center. And we know that we're going to have a radius to some point P, which we will call X, Y, Z. Okay? So all the points on the sphere from the center of the sphere, all the points are R units away, right? They're R units away. So what are we doing here? Well, note what I said. This point to every point on the sphere, and yes, it's three-dimensional, it's a sphere. So from the center of the sphere to each point, the distance is R. You see that? The distance is R. So the distance, let's see if I'm going to have enough room here. The distance of PC is equal to R. This distance from point P to point C is equal to R, my radius. And then what happens if I square both of them? Okay, so I can square both of them. So that's going to give me what? Well, what is this distance here? Okay, it's going to be, we'll call this x2, y2, z2, x1, y1, z1. So that's going to be what? x2 minus x1 squared. Okay, I'm doing the distance. Now, keep in mind I'm doing the distance, but I squared both sides. That got rid of the radical. So there's not going to be a square root. Plus y minus k squared plus z minus l squared, and that should equal this r squared. See, this squared is this left-hand side, and then we've got equal to the r squared. So this would be your equation for a sphere with center HKL. So that leads us to this right here. Equation of a sphere. An equation of a sphere with center HKL and radius r is what we just did. X minus h squared plus y minus k squared plus z minus l squared. That's what we got right here. And that's equal to r squared. And so another thing, if the center is at the origin O, then an equation of the sphere is, of course, h, k, and l would be 0. So we would put zeros there, and that would just leave us with x squared plus y squared plus z squared equals r squared, which is this right here. All right. All right, so I think we've got 2 more examples and we'll be done. Okay, so just bear with me. So this example, show that x squared plus y squared plus z squared plus 4x minus 6y plus 2z plus 6 equals 0 is the equation of a sphere, and find its center and radius. And you know what? I would be willing to bet that you already know how to do this. Do you remember when you had an equation that looked like this, but it didn't have the z terms in there? That was the equation of a circle. Do you remember how you found the center and the radius? You would complete the square on it, wouldn't you? Well, that's exactly what we're going to do here. So when I write this equation down, I've got x squared plus 4x. I'm going to group the x terms together and put it in parentheses and leave that little space there. You know, we do that when we complete the square. And then I've got y squared minus 6y and leave another space, plus, and then I've got z squared plus 2z, I'll leave a little space, equals, now remember your constant term, you would take that to the other side of the equal sign, so that equals -6. Now, do we remember how to complete the square? So you half the 4, which is 2, and then you square it, so that's plus 4. So that means we have to add 4 over here. And then the 6, we half that, that's 3. Square the 3, that's 9, so we have to add 9 over here. And then the 2, we half the 2, which is 1. 1 squared is 1, and so we add the 1. And so remember, this factors into x plus 2 squared plus y minus 3 squared plus z plus 1 squared, and that is equal to 8. And so our center is HKL, so that's -2, 3, -1, and our radius is what? Now remember, this is r squared, so r is the square root of that, which that would be 2 square roots of 2. And that's the answer they want. Okay. All right, so let's look at this. What region in R3 is represented by the following inequalities? So we got 1 is less than or equal to x squared plus y squared plus z squared, which is less than or equal to 4, and z is negative. So z is negative. All right, so how do we want to go about this problem? So we know if we had x squared plus y squared equals plus z squared equals 1, and we had x squared plus y squared plus z squared equals 4, that would be a sphere, right? That's the equation of a sphere. But what we can look at this is, if we look at this in terms of distance, if we look at it like a distance, we can actually write this as so I just square rooted everything. Okay? So what does that tell me that what I just did? It says so this represents the points x, y, whose distance from the origin, okay, so remember this represents distance, whose distance from the origin is at least 1, say it's greater than or equal to 1, but no more than 2. You see that? That's the distance from the origin. All right. So if we look at that, let's draw this. Let me get some more room here. So there's Z, there's X, and there's Y. All right. So it's the distance from the origin is more than 1, okay? Well, greater than or equal to 1. So if I look at that, that's probably going to be, that's going to look, see if I can draw this one halfway decent. All right. So this distance from the origin to any point on this circle here, that would be 1 unit. Okay, it's 1 unit. And then if we have another one, that's 2 units there, right? So I'll tell you, this is 1 and this is 2 units. But now also keep it and try to understand that this thing is laying flat. See, this right here, this axis is coming out this way. Let's see if that makes it look a little better. Well, and actually that wouldn't be hidden because that would actually be on top of that circle. See, that's laying flat on that XY plane there. And then it's going to come this way. Okay. That would be like the bottom half of that sphere, or half a sphere is basically what we have. So it's all the points here and here. It would represent all those points, and I know that looks terrible, doesn't it? So let's see if we anyway, it's supposed to look like a circle. Anyway, let's see. There we go. Something like that. Okay, that would be like the bottom of that sphere. And it represents, and that would represent all the points in there. Okay. And we know it's all below because it tells us that Z is less than or equal to 0. Now if it said Z is greater than or equal to 0, of course it would come up this way. Okay. So what we have is points lie on or below the XY plane. Okay, so they lie on that plane or below it. Okay. And the inequalities, it lies between or on the spheres. Okay, so you've got to understand that there's another sphere coming like this too. All right, so this would be that big sphere there, and then you've got this smaller sphere right here, and it lies between them or on the spheres. Okay, so it lies between the spheres or on the spheres. And what spheres are that? Well, that's x squared plus y squared plus z squared equals 1. That would be the equation of the smaller sphere. And we've got x squared plus y squared plus z squared equals 4. That would be the equation of the larger sphere. Okay, so it lies beneath or on the xy plane on these spheres here. All right, so hopefully that made sense. I apologize for the bad drawings. Hopefully you can draw better than I can. But anyway, that's the video. I hope it helped. I hope I didn't mess you up too bad with my terrible drawings. But check out my other videos. Give me a like, share, and subscribe. Thanks for watching. I'll see y'all in the next one. Later.